Okay, everybody, let's make some magic and get rid of these negative exponents in our algebra expressions. All right, so let's start. I have 6 to the negative 2. That does not make sense. I cannot write that 6 negative 2 times. So the rule is to make this exponent positive, you do the reciprocal, the multiplicative inverse of this base. All that means to do is flip it. Right now, 6 is a whole number. I can write it as a fraction by putting it over 1, because 6 divided by 1 is still 6. Now that I made it a fraction, I can flip it. Do the reciprocal or the multiplicative inverse. The 6 would go to the denominator, the 1 would go to the numerator, and now your exponent becomes a 2. And now we understand what that means. 6 to the negative 2 really means for us to work 1/6 squared, which we know is 1/6 times 1/6, and we're back to singing. Multiplying fractions is no problem. Top times top, bottom times bottom. And that's what we'll get 1/36. All right, our next expression, -4/9 to the negative 1. So what don't we like? We do not like negative exponents. Now look, you can have a negative number, and that's what the -4/9 is. That's a number. Numbers are on the number line, and they are negative. What we cannot have in math is a negative exponent because it doesn't make sense. How do we write this -1 times? We can't. So the rule is to make this exponent positive, you do the reciprocal of the base, the multiplicative inverse. We're going to flip this base. Now it's already written as a fraction, so all we got to do is change locations. The 9 goes to the numerator. The 4 goes to the denominator. Here's the problem. Where does the negative go? Well, we've talked about this. When we have a negative in the middle of a fraction bar, it automatically belongs to the numerator. So when you do the reciprocal, the negative sign stays with the 4 at the bottom, the denominator. But can you leave a negative sign in the denominator of a fraction? Heck no. We've discussed this. This makes no sense in math. If I say divide into -4 groups, how do you do that? How can I get people up to divide into -4 groups? I can't. That is why anytime we have a negative symbol, it floats to the top. So the reciprocal, the multiplicative inverse, a -4/9 is -9/4. And all that does is make the exponent positive. Now I understand that expression. This says write this base 1 time, and I will write it once, and I get -9/4. Awesome. Our third expression, -3 to the -3 exponent. Again, what do I not like? In math, we do not like negative exponents. They make no sense. You can have a negative number. I can have -3 in real life. I lost $3. But I cannot have a negative exponent. So the rule is to make this exponent positive, I do the reciprocal of the base. Well, I don't see this written as a fraction, so I'm going to fix it. Any integer can be made into a fraction by dividing by 1. Now I can do the reciprocal and flip it. The 1 would go to the numerator. The 3 would go to the denominator. I will not put the negative in the denominator because it automatically floats to the top. So the reciprocal in -3 is -1/3. What that allows me to do is make my exponent positive. Now I understand the statement. This says take -1/3 and multiply it 3 times. So this is -1/3 times -1/3 times -1/3. And a negative times a negative is a positive. A positive times a negative would make a negative. Top times top. 1 times 1 times 1 will always be 1. Bottom times bottom. 3 times 3 is 9. 9 times 3 is 27. And that's where you get the value -1/27. One note, if you want to go cheat and pull out your calculators and type these expressions into your calculators, realize you're not going to get out these fraction values. Your calculator is programmed to give you out a decimal value that's probably a repeating decimal, and no math instructor, no homework system that you're typing on wants those repeating decimals. So you need to learn how to change negative exponents to positive exponents on paper so you can work your expressions. All right, we're going to work more with this with algebra in the next video. See you then.